Hello, my name is Ryan Christopherson, and we're speaking to you tonight from a beautiful summer evening in western Minnesota. We're going to discuss the MT800 hydraulic stacks and our experience with them. So the video will entail a little bit description about my experience and how I grew up, and then our experience with the MT800 series tractors. Um, Also, what we've had to deal with since 2009 with the C models and the hydraulic stack on here, the various failures that we've had, and we're going to go through the reasons why the hydraulic stack is failing, and then the fix that we've come up with to implement to keep these tractors working in a meaningful fashion for the rest of their life. So once again, I said my name is Ryan Christopherson. I grew up here in southwestern Minnesota. At 17 years old, I went to the United States Naval Academy. There, I got a degree in mechanical engineering with a subspecialty material science, failure analysis, and ironically enough, hydraulics. From there, I entered the active duty Navy, and I flew aircraft carrier-based jets for 12 years. I came back here in 2003 to southwestern Minnesota, where I am running a fifth generation family farm with my family. And I also flew down at the Guard for another 6-7 years to finish out my 20 years. So we have these MT800 tractors. We love them. I started buying the Bs somewhere around the fall of 05, 06. We bought multiple Bs. We liked them. We had some transmission problems with them, with the plastic gears inside the transmission, the plastic collars. So we traded those off for Cs. We got our first C somewhere around the fall of 2009, and that fall, we got it late in the fall. We didn't even get 20 hours on that C. It was an 875C, because the hydraulic system actually just didn't work. I didn't think much of it at the time, because I figured, what are the odds you're going to buy a tractor and a hydraulic system is going to work? So that was fixed. We had a couple issues with the pump stroking. The collets were machined improperly, so the thermal plugs kept blowing. From 2009 to about 2014, I bought tractors. I kept buying tractors. And I accumulated quite a few of these. And then we didn't have a lot of trouble until about 15. And then from 2015 all the way up to about 2019, it was just nothing but trouble. When you have a properly designed, engineered system, you have relatively repeatable failure patterns. So with this hydraulic system, we had hoses blowing out the back, we had collets blowing out the back, we had leaks from the individual sections, we had ECMs failing, basically the entire hydraulic stack. And we could get, on a tillage tractor, we could maybe get 600-700 hours before we lost an ECM. On a planter tractor, we have one planter tractor that we didn't have any trouble with. We've had very limited trouble in 3,200 hours on the tractor. We had another tractor, planter tractor, and they're running Deerbauer 40-year-old 20s, where we couldn't get maybe 15 hours between an ECM failure and replacing components on that tractor. So what that tells you is you've got multiple failures in the systems. They're either A, not designed for what they're doing, or B, they're not operating in the correct environment. And there's two things that ruin hydraulic systems. The first is overpressurization, getting up. Essentially, this system is pressure limited to 2988. You can get up to 3250 under certain circumstances, but you get over that 3,500 psi, that's where you start to have a lot of failures. The second way to get a lot of failures is a temperature problem, and that is generally created by restriction. So that the tractor will start to cool the hydraulic fluid around 148 degrees. In some of the hydraulic stacks, we saw the temperatures getting up on the hydraulic stacks in excess of 175 degrees. A Buna O-ring is what's in these hydraulic stacks, and they work at 140 degrees. They start to rapidly degrade at 190 degrees. So the crazy thing about this is we have all these tractors. We have roughly 30 to 35,000 hours operating these tractors since 2005. And I couldn't pin down why we were having these failures, because they were so diverse with so many different times. So we bought we bought flow meters and pressure gauges. So we started testing under various operating circumstances what we were seeing for pressure, what we were seeing for the temperatures. And we quickly deduced that almost all the problems were based and due to temperature. They weren't due to pressure, which leads us down to the standards. When you're designing a system, you typically start off with standards. And those standards for these tractors are the ISO series of standards, and in particular, they are ISO 5675. And that's what delineates all the standards for agriculture tractors, the hookups, and all that. For example, this is a ISO 8010 half-inch connector. This is what farmers use non-stop. Well, the funny thing about this is this ISO 8010 is rated for 12 gallons a minute. Max flow of 24 gallons a minute. So a 3/4 inch coupler is rated for 28 gallons a minute with a max flow of 50. So we started checking these, and what we found out is we have 30 gallons a minute coming out of each individual outlet on the stack. If you get over 24 gallons a minute, basically you have restriction. You start to heat up the hydraulic fluid, and you break down the hydraulic stack. So we're going to go over 8 different failure points of this hydraulic stack and this hydraulic system, and some are building up restrictions and some are increasing the temperature. There are other just physical problems with the stack leading to other problems, multiple failure modes. So one of the things in the Navy that we always had a saying is never fly the A model of anything, and that is held true to an airplane. My feelings on this stack is it's the A model. It didn't really exist until 2009, and they started putting them on these tractors. So basically, we paid to troubleshoot a hydraulic system that was just invented. The valve that we'll go over here in just a little bit is called the PVG 32 valve from Sauer-Danfoss. It was originally started out in 1975 as the PVG 60 valve. In 1988, it moved into the PVG 32 series, and it's been the same valve since 1988 till now. Millions and millions and millions of those valves out right now. If you drive an auto steer tractor or a piece of equipment, it's very likely that you have a PVG 32 valve stack that you don't know about. The company that I'm dealing with that helped me design the system and the software, I asked them to look at their records, and in the last 13 months, they sold 11,000 of those valve stacks with 47,000 individual sections in the valve stacks. So with this, you are not flying the A model in any way, shape, or form. All right, on to the individual issues with this stack. So the first basic problem that we kind of touched on was that this half-inch Pioneer 8010 outlet can only accept 24 gallons a minute. If you go over 24 gallons a minute, you can push more through it temporarily, but as you push more through, you create that restriction and you rapidly heat the oil up. So that's one of the problems is we're heating the oil up. Some of the new tractors coming out, I have seen that they're recommending 21 gallons a minute from each individual outlet. Now, so that's the first problem. We're pushing too much oil through there. The second problem basically boils down to the slope of the control on the hydraulics up in the cab. Now, if you put 50% flow rate in on the display in the cab, you would think that you're getting 15 gallons a minute if you knew that you were getting 30 out of it, but that's actually not the case. So at 50% flow rate set in the tractor on the armrest monitor, you're getting 21.8. So that means if you're ever above 50% flow rate on your each individual hydraulic outlet, you're actually heating up the oil. So no matter what you do here, I recommend that you run all your hydraulic outlets at 50% flow rate. If you run any greater than that, you're heating them up. So one of the things that I did when I started looking at this system was I took about a year and I started looking at all the various hydraulic setups that were on differing tractors, every color, every make, every model. And I found it to be interesting because The hydraulic stack that has the outlets integrated with the stack is largely a phenomenon of a two-wheel track tractor. If you start looking at the quad tracks and the four-track tractors, a lot of them have stacks similar to this mounted up on the back, and then you've got remote outlets there. And that kind of cued me in a little bit to what was going on. The third problem after the excessive flow rate, the slope of the control, is this valve right down here. And that's a load sense pressure limiting valve that's built into the stack. Now we've got hydraulic stacks that have gone 2,500 hours with very little trouble. And in 2017 or 18, I bought a 6-valve stack from my dealer, and I thought that we were just basically going to replace our stacks every, whatever, 1,500 hours. Well, the problem was we didn't even get 20 hours on that stack, and we had a failure of an ECM, and then pretty much by 40 hours, we had every stack leaking, and all of the collets were blown out. And I couldn't keep a hydraulic hose plugged into the tractor. So one time it was late at night, I was planting, very frustrated. I just spent 10, 12 grand on a new stack, and the hose blew out, and I grabbed the hose, and the hose was so ungodly hot that it almost burned my hand. And that's what kind of cued me in. That was my one eureka moment that we had a problem here. And I believe that the problem basically is the load sense limiting valve. What's happening is we've got, on a certain amount of stacks, we've got fluid leaking by there, creating a restriction, and then that restriction heats the oil up excessively. So we're well over 190 degrees fluid temperature on some of those stacks, not all of them, just some of those stacks. Okay, so we've covered those three problems. Now the next basic problem that I see is all of the pressure and the return lines go to the bottom, and all of the flow starts at the bottom, and it works its way up the stack. Well, we've already discussed that you need a 3/4 inch line and outlet to flow 50 gallons a minute. Well, here, this is one individual section of the stack. So you can see the O-rings that I'm talking about, these Buna O-rings that steel up between the stack. And right here is your pressure and the return. And the problem that we have there is they're not even 3/4 inch. They're just slightly over 5/8 inch. So now as all the flow rate comes in the bottom, the way we typically run our outlets are, we use the first couple for the lift in the fold functions, and we use the top basically for the orbital motors. Well, now it's pretty much exactly what you'd want to do, because now all the flow rate is coming up from the top, from the bottom to the top. You don't have enough surface area for that oil to get through there. You're creating restrictions and you're creating heat. You can see that on the stacks that we've got here, we're coming in between the 4th and 5th outlet basically, and we're splitting the flow in our stack. So that's the 4th one. Now the 5th problem that we have with this stack is it's offset. And you can see I've moved the hydraulic hitch all the way to the right. And these are the collets that you've got inside your individual stack, here and here. They're roughly $230, $40 a piece. You get them through some of the aftermarket places. They're roughly $350. So you've got $700 per outlet. And at that point, you've got labor to put them in. So you got about $1,000 per outlet. Now, if you think about your hydraulic hoses, and they're sitting here, and you think about your hitch on your digger is all the way over here, or if you're a planter, you're in the center, but you've got 6 or 7 sets of hoses here, and you turn aggressively. Think of the force that you're putting on this collet. If this stack were in the center, you'd still be putting a semblance of force on it, but much, much less, because wherever your pivot is, that's where you're moving. So with that being said, that's the 4th one. Now the 5th one that we've got a real problem with is in this stack, it's held together by 4 rods that go down through the stack, and they're tightened up, and it's holding everything together. Now think about, as we discussed, on this individual stack, you've got your O-rings here. Now think about, you've got a hose plugged in the top and the bottom, and you take a very hard turn. Think about how those individual plates are moving. So it's not real, it's really not confusing when you sit down and you look at all these different factors of why we're having trouble with this. The last real problem that I see is the common rail, what I call the common rail. So inside this stack, no matter if you engage the third one, the fifth one, or the first one, it pressurizes this entire side. And it's the same for this. Whatever you engage, it pressurizes this. So if any one of these is leaking, as soon as you do that, it shoots all the hoses out the back. Now, honest to God, can't tell you as many times I've been outside the tractor. A hose will decouple, and I put it in the other side, hoping that the other side is still good. And I have to search, on a digger, it's not a big deal, or a grain cart, but on a planter, you're using every single outlet. So the problem with that is you have to keep searching or keep putting these in. And we've rebuilt these. We bought aftermarket, we've bought OEM, we've bought everything. Some tractors will last 500 hours, some will last 1,000, some will last 10 hours. It seems to be no rhyme or reason other than basically the heat of the system and how you're building it up. So with that being said, the last thing is the ECMs. I would have to add up how many ECMs we've gone through, but it would be in the neighborhood of 50, at least 40, if not 50. And at $1,000 a piece to program, we're talking $30,000, $40,000, $50,000 of ECMs that we've gone through. And the irony is it's not even really the ECMs are the problem, because you've got your directional and your proportional valve here, and when your stack heats up and your O-rings get brittle and the O-rings start to leak, now these leak internally, and then that shorts out the ECMs. So if you're replacing your ECMs, it's wise to replace your proportional valves and your directional valve at the same time. It's likely it's not even the ECM. So with all these troubles that we've had with this hydraulic system, we kept replacing pieces, parts. We kept replacing all the parts, and we got to the point where our tractors were nearly unusable. And for me, that's a problem, because we use these on our scraper, on our tile plow, on our grain cart, on our planter, on our tillage. We use these for everything. We in fact don't own any other tractors on this farm, because what we decided to do is keep everything centralized. You have the same oil filter, the same fuel filter. You've got no training once the person gets trained up in the tractor. So it gave us a unique problem, because if we have no parts, we can't keep the tractors running. Now we actually are at the point where our whole system of running our farm was running aground. So we either had to come up with a solution, or we had to start trading off the tractors. And anybody that's looked at equipment lately, to get a large high horsepower tractor, you're in the neighborhood of 500,000 to 800,000 to trade. So we were looking at, $4 to $5 million to trade off our tractors. So I decided that a farmer on a day-to-day basis, you're doing all the work, you're trying to keep everything going, you're doing day-to-day operations, but there's very little time for what I call high-level thinking, or trying to go in a different direction to figure out your problems. So it actually occurred to me after we bought that new hydraulic stack that failed after 20 hours that we were going to have to come up with a solution ourselves. So in 2019, it took almost an entire year to figure out what we were going to do. And I looked at all the different hydraulic systems out there. Very surprising to me that you've got essentially 3 manufacturers. You've got Bosch Rexroth, you've got Pioneer Parker, and you got Sauer Danfoss. And that's pretty much it in the hydraulic world for agriculture. So you've got those 3 to pick from. And then inside that, since very few other than the OEMs can deal with those companies, I've got to find somebody that can help me do what I need to do. And it took a while. Took a little bit of convincing that we could actually come up with a product that would work. So in engineering, like we spoke about, you have to come up with a set of conditions. So there was a lot of parameters that we had to come up with, and our goal was to put a system on these tractors that connected to the 5 physical connections of the hoses, which is the pressure, the return, there's a load sense line to the pump, there's a load sense isolator line to the priority valve, and then a true pressure reference valve that goes back to the hydraulic pump to control the pressure. So we hook up to those 5 outlets just like the normal stack. However, as far as the wiring, we have our own display, we have our own switches, we have our own wedge box, we have our own wiring harness. Everything is separate and independent. The only thing that hooks up to the tractor for electrical is a 3-pin round connector. So what we did was we built the first 6 or 7 wiring harnesses ourselves, and then after we got the dimensions and we got the pinout diagram, we have these professionally made, and this is what hooks in basically to the 3 round pin. This comes in the back of the cab, hooks up to all the hydraulics, and then it hooks up to the wedge boxes and the display. The real interesting thing was, when we pulled the armrest apart, what we found was a Sauer Danfoss wedge box that's actually the armrest ECM in these tractors. So we're using the identical ECM down to the part number that is in the armrest that controls the original hydraulic setup as well as the rest of the armrest functions. So what we do is we've got a real nice, and there's some videos on the webpage, we've got a real nice 7-inch color display that actually runs it. Now, point of note is this runs the setup. It doesn't run it, it actually displays and allows you to change the hold features, the flow features, and the troubleshooting of this. But if the screen were to go out when in the middle of the season, you'd still be able to run your hydraulics. The actual operation of the hydraulics is done through the wedge boxes. We pull out the original OEM switch, and this goes in the armrest. We've got a laser cut Lexian backing plate that goes in and screws. So you've got armrest switches that are the same. These switches have no actual float function. So what we've got is a button where you push the button 1 through 6 for float, and it puts your implements into float. And then anytime you actuate the switch, it takes it out of float and puts it into what you have programmed. So what we decided to do was use these Pioneer 9500-4 outlets. These are a 1/2-inch pipe thread on the back, and coming out of the stack itself is a 5/8. So we reduce it from 5/8 down to 1/2 inch right away. And the benefit of these are that they're roughly $220, and they're attached just to 2 threaded rods through the middle. And it is kind of strange that this is $350. There's 2 of these in here, and you can buy this for $220. So we ran the first season. We ran 5 of these the first season this past, and I ran probably about just under 200 hours with a Deerbauer 4820 with this 7 outlet setup. And in the 200 hours planting, we had 0 disconnects on the back. And if we did, and we had a problem with an O-ring blowout, this could be replaced for $230 in roughly 5 minutes. So if you don't necessarily want something like this, or if you want to go to a little bit higher flow rate and you go to a 1/2 inch, we go to a 3/4 inch, we can go from 5/8 right into 2 3/4 inch couplers, so such as an air fan, you know, on a large air cart. Now, one thing to note, I don't want to put all of the trouble on the OEM and the dealers, because they put a system out there and the farmers take it, and there are a million different uses for these hydraulics. And one thing that we've fallen down on is the quality of our connector. You know, I can't tell you the number of times that I haven't been able to hook up an outlet, a hose to an outlet. So I take the hose and I bang it on the hitch of the implement, and I mar this up, I get it sharp, I cut it. Off season, these lay in the ground, they get rusty. So what we created was a go, no-go gauge. We're just a few thousandths over what the 8010 spec is. And basically, if you have much play in here, or if it's ovaled and it doesn't fit in, or if you have sharp edges, you need to replace these. These are roughly $14 a piece, very cheap. We treat these as consumable now, because once we made this no-go gauge, I was surprised at how many of our tips failed. So we're replacing our tips about every 3 to 5 years now. If not, then we end up replacing O-rings and collets. All right, so we've discussed the failures with the stack. We've discussed why the stacks fail. Now let's discuss what we've done. So this is the first version of what we created. and we're happy with it. We won't change it, but we have a second version of it. So the first problem was we're getting 30 to 31 gallons a minute out of that stack, and we know that the flow rate for this is max 24. So the very first thing we did was limit the flow rate out of each individual outlet of the stack to 24 gallons a minute. The second problem was the slope of the control. So at 50% flow rate, you're getting 21.8, or you're nearly maxing this out. So what we did was we made the slope linear. So if we know 100% is 24 gallons a minute, then we know at 50% we're getting 12 gallons a minute out of it. So we have no load sense pressure limiting valve in this. There is a load sense safety bypass valve that will actuate at a certain PSI, but that should never come into contact. So we eliminated that valve, load sense limiting valve, completely. That was very important. Now, as far as the offset, you can see that we had to place the outlets directly in the middle over essentially the pin, and that was very, very important. So what we had to do was we had to offset the stack to the side, and you can see this first variant is a little bit low, and we'll go over the second variant here. Well, let's do that now. So with the second variant, what we did was we raised the PVG 32 valve stack up. So now the pressure and the return lines are going directly into the tractor. And what that allowed us to do is get just a little bit longer lines here because they're very difficult to hook up. These are just with being a farmer and wanting to be able to fix things, all these are gates. You've got 1/2-inch flat face O-ring, you've got a long neck and a short neck, and then you've got flat face O-ring on the end. So if you have the fittings, they can be made in nearly any auto parts store, anybody with a Gates crimper. So, like I said, we moved this stack up, we made these a little bit longer. We've got our stack, our outlets directly in the middle, and we can hook up under pressure. Now, the other thing that we did was, when we limited these to 24, because we're reducing a 5/8 flat face O-ring to half right off the bat, if you were running an air cart, what you would do is you would come in on either side of the inlet and outlet, and you would go from 5/8 to 3/4, and all you would do is mount 2 3/4 outlets there, and you'd be able to get 60 gallons a minute with good flow rate out of these two if you had a large fan. So this was well thought out, basically. And then once again, since there are millions and millions of these out there, we don't have too much, they don't have too much problems with electronic control, and that was one of our biggest goals, was to eliminate it. Now, one other goal that I had was to be able to actuate this from the ground. And you can see on this first stack, I left the handles in, but one of the very nice things is, if you want to, you get a set of handles with this. If you want to actuate each individual stack, you can pressurize it or go to float, so you don't have to crawl back up in the cab anymore if you want to raise the digger or fold the wings or do that. So what I like most about this system is it's relatively simple. The only proprietary piece on the entire system is the software, which shouldn't need to be flashed or programmed at all. And the system can be fixed. You can buy parts at any local shop. The PVG 32 valve can be serviced by anybody, relatively few failures. As far as the outlets, now we have a 7 stack. We started off originally with a 7 stack, and that's a little bit challenging to plumb, and it's a little bit challenging to fit everything up in the cab. So we've kind of gone down to a 6 stack. One of the questions people ask me also is, why don't you have a Power Beyond? Well, the problem with the Power Beyond is this has a 3/4 inch coupler, but the Power Beyond in this setup is only rated for 16 gallons a minute. So it's more or less irrelevant. If each one of these is rated for 24 gallons a minute, then we really have no need for a Power Beyond. We can do a 7 stack setup. Like I said, it's a little bit more challenging. So on this, our planter tractor, we added in a manifold to go to free flow return. So the 2 additional outlets on top are 4 free flow returns. If you're using all of your outlets, you technically may need that. But if you have 6 outlets and you have 1 or 2 free, all you need to do is go to float on this outlet, and you could plug free flow returns right back into the stack on both sides, and you really would have the same functionality of what I have. So that's about all I have for this video. I hope you found it informational. I hope you learned something from it. This was very hard-fought information that took years and years and years to learn. And we're going to go ahead and put my phone number on the website. If anybody has any questions, you can give me a call. I'm fairly busy, so if I don't answer the phone right away, I will get back to you as soon as I can. Any feedback that you have, you can email on the webpage or you can call. But my perspective is, with all these different various failure rates, if they're not addressed in a timely and orderly fashion, any fix that's created for these hydraulic stacks is just a band-aid. And basically, it'll result in reduced operating efficiencies for the tractor itself. With that, I'll sign off for the night. Thank you for your time, and I hope to talk to you soon. Thank you.